Good day, grade 12 learners. Today we are continuing with our revision session. We are looking at mathematics paper 1. We are gonna be talking about the functions. In paper 1 we have 6 functions, and overall we have 7 functions. But the 7th function is in paper 2, which is called the trig function. Today we are gonna be looking at the 6 functions we have in paper 1, starting with the linear functions. You remember that linear functions are given by y is equals to mx plus c, where your m is your gradient, your c represents your y-intercept, and this is the standard form of it, and this is the expanded form of it. The y minus y1 is equals to m into x minus x1. They are all the same, but this is the standard form and this is the expanded form of it. And we will talk about the parabolic functions. We have 3 equations of the parabolic functions. The standard form of a parabolic function is y is equals to ax squared plus bx plus c. And then we have here the root form of it. We have y is equals to a into x minus x1 close brackets. We have x minus x1 close brackets. Like you use this equation here when they give you the two roots of the equation and any random point. You put the x values here on x1 and x2. You put the random point that they give you into this x and y here, y. You put the x values here and you put the y value here and you solve for a. We have the third equation here. You only use this equation when they give you the turning points and any random point on the graph. You put your x coordinate of the turning point here and you put your y coordinate of the turning point here, and you put the x and y values of the point they gave you there to solve for a. And we will look also at the hyperbolic functions. The standard form of the hyperbolic function is y is equals to a over x minus p plus q, where p and q represent your asymptotes. They will give you asymptotes of the x and y asymptotes. You put the x asymptotes here and the y asymptote here, and they will obviously give you a random point where you put its x and y values here. Put its x value here and its y value here and you solve for a. We will also look at the exponential functions and the logarithmic functions. Like these two, they are inverse of one another. Exponential function is an inverse of logarithmic function, and logarithmic function is the inverse of exponential function. The standard form of exponential function is given by y is equals to a into b to the power x minus p plus q, where p and q have their unique roles to the graph. And the logarithmic functions, we have y is equals to log of a into x plus q, where a and x play their own unique roles. We will do many examples on these functions here, and to see how to solve each question. And then we have the cubic function. The cubic function is given by y is equals to ax cubed plus bx squared plus cx plus d, where d is the y-intercept. A, B, and C, they play their own unique roles. And then within these functions, we will be dealing with the range. Remember that the range is all possible y values of a function. They are all possible y values of a function. And the domain, where domain means all possible x values of a function. Remember, each function has its own domain and range. They differ. We will look more into that when we're doing examples on these functions here. We'll also be looking at where the functions are increasing. That means f of x is greater than 0. We'll be looking at where the functions are decreasing, where f of x is less than 0. We'll also look where they are strictly increasing, where f of x is greater than or equals to 0. We'll also look at where they are strictly decreasing, where f of x is less than or equals to 0. Remember that 0 here is the line of x-axis here. We want to know all the x values where your function is below that line here, the line of x-axis. But we will look at many examples on how to answer this type of question, because they like asking them a lot, you know. They will say like, for which values of x is f of x greater than or equals to 2, or for which values of x is f of x strictly increasing, or for which values of x is f of x decreasing, and so on and so on. We'll be looking also at the inverse functions here, given by this symbol here. This symbol does not mean that it's 1 over f of x. It means that this equation here is the inverse of f of x. Don't take this as 1 over f of x, because you will regret later. And lastly, we will be looking at the axis of symmetry, where your graph on the left hand side is equals to your graph on the right hand side. When we talk of axis of symmetry, we will be looking at the parabolic functions and the hyperbolic functions. This was just the introduction to functions. Of course, we will look at the nature of roots as we go on, and I will do many practice problems concerning these functions of grade 12 mathematics paper 1. For now, I want to take an example, you know, from let's do example, but I will do it in a different video so that I keep these videos short and simple. I guess I will see you in the next video. Bye.